Welcome to today's ArXiv CS Digest for April 21st, 2026. We received 781 new computer science papers today across 58 subfields. Let's dive into the top picks. Trend 1 of 5, Generative AI for Vision. These papers explore generating and manipulating visual content using AI, from realistic virtual try-ons to 3D reconstructions and video synthesis. This cluster covers 168 papers. Representative work includes STARS Try-On 1.0, robust and realistic virtual try-on for diverse fashion items, any recon. Arbitrary view, 3D reconstruction with video diffusion model, and city RAG, stepping into a city via spatially grounded video generation. Trend 2 of 5, LLMs for reasoning and prediction. LLMs are being leveraged to enhance logical reasoning, predict outcomes, and generate insights across diverse domains. This cluster covers 215 papers. Representative work includes discovering a shared logical subspace, steering LLM logical reasoning via alignment of natural language and symbolic views, regression with large language models for materials and molecular property prediction, and cross-family speculative decoding for Polish language models on Apple Silicon. An empirical evaluation of BELIC 11b with UAG extended MLXLM. Trend 3 of 5, Deep Learning for Science. Deep learning is being applied to solve complex scientific problems, from materials science to physics and optimization. This cluster covers 150 papers. Representative work includes accurate and scalable exchange correlation with deep learning, generalization at the edge of stability, and phase transitions in the fluctuations of functionals of random neural networks. Trend 4 of 5, AI for Code and Values. This trend explores AI's role in code development and the integration of ethical values into technological systems. This cluster covers 122 papers. Representative work includes PlayCoder, making LLM-generated GUI code playable, revisiting code, debloating with ground truth-based evaluation, and Spec Agent, a speculative retrieval and forecasting agent for code completion. Trend 5 of 5, Machine Learning for Data. These papers apply machine learning to understand, improve, and optimize data's quality, characteristics, and its utility within ML systems. This cluster covers 126 papers. Representative work includes MapPFN, learning causal perturbation maps in context, FBNLL, a feature-based approach to tackle noisy labels in personalized federated learning, and adaptive MSD splitting, enhancing C4.5 and random forest for skewed continuous attributes. Up next, our first paper out of 5, Hybrid Architecture for Language Models, Systematic Analysis and Design Insights by Sangmin Bai and Carol Jean Wu from Ferret Meta. Let's break down its key contributions. This work systematically evaluates hybrid language architectures, combining self-attention and structured state space models. It investigates interlayer and intralayer fusion strategies for improved efficiency and performance. The paper conducts a comprehensive evaluation across multiple dimensions, including language modeling, downstream tasks, long context capabilities, and efficiency. This provides a multifaceted understanding of hybrid model effectiveness. By analyzing core characteristics and identifying critical elements, the study proposes optimal design recipes for hybrid models. This offers practical guidance for developing and optimizing future architectures. Up next, our second paper out of 5, Security is Relative, Training-Free Vulnerability Detection via Multi-Agent Behavioral Contract Synthesis by Yongxiao Wang and Zhiqiu Huang from College of Computer Science and Technology, Nanjing University of Aeronautics and Astronautics, Nanjing, China. Let's break down its key contributions. This component extracts minimal, vulnerability-relevant code context from input. It focuses on isolating the essential parts of the code necessary for subsequent analysis, reducing noise, and improving efficiency. This stage synthesizes Gherkin behavioral specifications. These specifications encode the project-specific security contract, distinguishing between vulnerable and patched code based on observed behavior. The final stage evaluates the code against the synthesized Gherkin behavioral specifications. It performs a strict compliance check to determine if the code adheres to the defined security contract. Up next, our third paper out of 5, GRAIL, Learning to Interact with Large Knowledge Graphs for Retrieval Augmented Reasoning by Changge Wu and Jian Pei. Let's break down its key contributions. GRAIL establishes a data synthesis pipeline by integrating LLM-guided random exploration with path filtering. This automatically generates fine-grained reasoning trajectories for each task, providing structured training data. A two-stage training process is employed to learn a policy that dynamically decides optimal actions at each reasoning step. This policy is trained on the synthesized data to guide graph interaction. To enhance data efficiency and training stability, the objective of precision-conciseness balance in graph retrieval is decoupled into fine-grained process-supervised rewards. This guides the policy learning effectively. In deployment, GRAIL adopts an interactive retrieval paradigm, allowing the model to autonomously explore graph paths. This dynamically balances retrieval breadth and precision, enabling adaptive reasoning during inference. Up next, our fourth paper out of 5, Unsupervised Confidence Calibration for Reasoning LLMs from a Single Generation by Thomas Zallo and Richard Zemmel from Columbia University. Let's break down its key contributions. The method initiates with offline sampling on unlabeled data, generating multiple reasoning paths for each input. This foundational step is crucial for creating a rich dataset without requiring expensive human annotations. From the multiple offline samples, a self-consistency-based proxy target is derived. This target quantifies the agreement among different reasoning paths, providing a robust and unsupervised signal for confidence estimation. The derived self-consistency signal is then distilled into a lightweight deployment time confidence predictor. This final component enables efficient and accurate confidence calibration from a single LLM generation at inference time. Up next, our fifth paper out of 5, Beyond Semantic Similarity, a component-wise evaluation framework for medical question-answering systems with health equity implications by Abu Noman MD Sakab and Zijia Zhang from University of Texas at San Antonio, USA. Let's break down its key contributions. This component assesses the model's ability to accurately identify and extract medical entities from its generated answers. It is crucial for ensuring the foundational accuracy of medical information provided by LLMs. This component measures how closely the model's answer aligns semantically with a reference answer. It evaluates the fluency and general meaning, but the paper argues it's insufficient alone for medical accuracy. This component rigorously checks the factual accuracy of the information presented in the model's response against authoritative sources. It is vital for preventing the dissemination of medically incorrect information. This component evaluates whether the model's answer provides all necessary and relevant structured medical information. It ensures comprehensive and actionable responses, particularly important for patient understanding and decision-making. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.